In this video, we're going to talk about properties of logarithms and how they actually correspond to properties of exponents. What we're going to eventually see in future lessons is how to solve logarithmic equations. And before we can do that, we must learn how to manipulate our logarithms, either condensing them to one logarithm or expanding them. But first, I want to focus on properties of exponents because logarithms are inverses of exponential functions. These are all different properties of exponents. I have highlighted three of them here. Right? This one is when we have common bases and we're dividing with exponents. This one is when you are raising an exponent to another exponent, like this whole term with an exponent raised to another exponent, as well as here we are multiplying a common base with these exponents. So just as a reminder, when you are multiplying common base of a, you add the exponents. Here, when you have a common base a, we subtract the exponents. And when you have some base raised to an exponent raised to another exponent, we multiply these exponents together as a way to simplify. So the same rules apply with logarithms. When we have these logarithms, log base 4 of 32, subtract log base 4 of 2, we have to make sure that these have the same base before we can continue. And as you can see, they do. They both have a base of 4. So you can see that with these logarithms, they are subtracting. It's very similar to what we see here with our quotient property. They are subtracting. So it's almost like instead of having our multiplication, so it's addition, division, so it's subtraction, we're going to go backwards this way. So see how it's subtraction, we see it's subtraction here. This is what we call our quotient property. So when they're dividing within the logarithm, you would subtract. So since we're going from subtraction, we want to divide within the logarithm. So I'm going to rewrite this as log base 4 of 32 over 2. And that can be simplified to log base 4 of 16. Now I could continue this and say this is actually 2 because 4 squared is 16, but I'm going to leave it as log base 4 16 just to show the simplified logarithm. One of the biggest errors that I see from this is a lot of students will take this logarithm here, right, this expanded logarithm, and they'll write log base 4 of 32 divided by log base 4 of 2. Please be very careful, right? Do not write this. This is wrong. All right, we're not doing the change of base formula when we are writing our subtraction. All right, so please make sure you are taking that logarithm. You see the subtraction, that's our quotient property. So we're going to write it as a fraction or division here of 32 divided by 2, which in this case was 16. Let's look at the second one. I see here that there's a 6 times log 2x and a 5 log base 2x. This is again multiplication, and there's an addition sign in here. So using our properties, I know that if I have something multiplying by the log, it's very similar to our multiplication of our power property of multiplication here. So we can simplify that by taking our log base 2 of x and raising it to the 6th power. And I'm going to add log base 2 y to the 5th power. I have to do that first. Whenever we are simplifying, we think of our order of operations. We work with parentheses, then exponents, then multiplication and division, then addition or subtraction. So here, when I'm simplifying, I want to work with that multiplication using our product property and moving them to the exponent. Our next step is seeing that this is addition. That's going to use our product property. So inside of one logarithm, what you would get is log, I'll go back to the original color, log base 2 these are going to multiply within that logarithm. So x to the 6th, y to the 5th, within that one logarithm. Let's take a look at a few more examples. I see here that we have addition. We want to condense them into one logarithm. I could have separated this even further, but for now we're only looking at just one single logarithm. So noticing that that's addition, this is going to be the product property. So log base 4 of 5x times the log of 3x, all in the same logarithm. So if I were to simplify this, I could write this as log base 4 of 15x squared. That is condensed. Let's look at the second one. Here I see subtraction, so we're going to have the quotient property, and I see that this log is being multiplied by 2, so we're going to have a power property as well. So I want to simplify this power property first. Power property should be first here, so I'm going to write log base 4 of 6 squared minus the log base 4 of 9. I can simplify that. So log base 4 of 36 minus log base 4 of 9. Now we can use our quotient property. I can rewrite this as log base 4 of 36 over 9, all within one logarithm. And we can simplify that a little further to become log base 4 of 4. Now that's writing it as one logarithm, but as we've seen in other lessons, if you have the log of base 4 with a solution of 4, that's really equal to 1. Why? Because 4 to the first power equals 4. But you can leave that as your simplified logarithm. In this next part, we're going to do the opposite. We're going to expand the logarithms. So using these properties again, product, quotient, and power, I want to take our logarithm that was condensed, and I want to expand it. So I see here, I see some division, as well as I see some multiplication in that numerator. First, I'm going to separate that division. So I'm going to write this as the quotient property, which is the log of base 10 in this case, because you can see that there's nothing written there, so that's our common logarithm. But I'm not going to write 10, you can leave it as log. Log of 4x minus the log of y. And then I can expand this even further to be the log of 4 plus the log of x, and then we can subtract the log of y. So if I were to actually go from the expanded logarithm back, going from left to right, our order of operations, I'm going to multiply these two together to become 4x. Then I would divide that product by y, so 4x over y. This would be the simplified logarithm. Expanded logarithm, excuse me. Let's take a look at the next one. Log base 9 of x to the 4th over 729. I could use my quotient property again first. I'm going to write this as the log base 9 of x to the 4th minus log base 9 of 729. And now I can use my power property because this has an exponent. So I'm going to write this as 4 times the log base 9 of x minus log 9 of 729. Now, this is expanded. This can be simplified. So just to show us a simplified version of this expansion, I'm going to write this as 4 log base 9 of x minus the log base 9 of 729. If I were to actually evaluate that, is equal to x, 9 to what power equals 729? Well, 9 cubed is actually 729. 9 times 9 is 81. Times 9 would be 729. So I could actually write right here that this logarithm of 9, base 9 of 729 would actually be 3. Because that is our exponent here. Right, this can evaluate to become 3. So this would be our simplified expanded logarithm. Let's look at 2 more examples. Log of base 3. I see here that this is being divided. So that's going to be our division. It's going to be our quotient rule property. So I can write this as 250 minus log base 3 of 37. I don't believe either of these numbers can be simplified. They do not have a common base, especially with 3. 3 raised to what power equals 250? I don't know. So I'm going to leave this as just that simplified logarithm. Last one, log base 3. I see here that there is multiplication, but there's also that exponent. So my first step, I want to separate these using the product property. Then I can use the power property to simplify this second term. So it's going to be plus 5 log base 3 of x. Now here I can leave this as the expanded logarithm, but you may have noticed already that log base 3 of 9, in this log base 3 of 9, I could solve for actually what that would have, or sorry, evaluate what that could be. I could rewrite this as 3 raised to the x equals 9. Well, 3 to what power equals 9? It's 3 squared. So this logarithm of base 3 to the 9, or solution of 9, could actually be just 2 as my expanded logarithm.